So here at Air Studios, where you have this great launch event, we're in Studio 1, where there was the sort of the band tracking side of things. We had a look at Studio 2 with Fab, where he showed us the sort of demo side, and then we had the fantastic orchestral piece, which blew my mind.
Right.
But now we're talking to you about the new Apollo X. So,
Right.
you know, that's launched now, and what it sounds like it's quite a major change over the previous generation.
That's right. Well, the idea is, you know, it's our third generation Apollo. So, you know, in our minds, you can't just iterate and do another pass at something and maybe make it a little bit better, a little bit better here and there. We really went down to the table and redesigned almost everything in the box. So from the A to D to the processing with hexacore processing to the D to A, the clocking, all the underpinnings of what make an audio system sound great, we've addressed, and we've really worked hard to make some stellar specifications. I mean, you got to hear it. I would say that's the most important thing that we tried to go after is these are amazing sounding interfaces.
So it's interesting. I mean, you've gone for 6 DSP cores across the whole range, and it's really a question of what I/O you would necessarily want.
Exactly.
But I mean, rewind a bit. I mean, you're saying you've reworked the mic amps. Some of them have got unison, some of them are lines.
Yes.
But still, the D2A and the AT, the clocking. The clocking is interesting. I heard someone talking about there being 2 clocks in this. So
that's right. Yeah. So a lot of interfaces generate all the clocks across the sample frequency range from a single crystal. So they'll take something. Most people favor 48K. So you'll see quoted specs at 48K, and you know some of them are pretty good. But really, what has to happen if you're working at 44.1 and your clock is a 48K clock, you have to multiply it and then divide it back down, and then do some sort of tricky math to get a stable clock over to your DACs and your A to Ds. So what we've done is put 2 crystals in. So we have a dedicated crystal that generates all the 44.1s and its multiples, and the 48s and all its multiples. So it's a simple, just multiply it up, and there's the right frequency for
so
88.2.
no rounding or jitter, and that really
Yes.
reduces the jitter and stuff. Right?
Exactly, and so this is a very clean, incredibly low jitter system. I mean, we're seeing sub 10 picosecond jitter across the board at all sample frequencies and across all units. So we've really, that's been a huge engineering effort for us, and we're really happy with the way it turned out, because what that does is give you a solid foundation to record on. You know, jitter is anomalies in the time domain, and so if you
Well, it affects imaging and top
Everything.
end and all sorts of stuff.
Yeah. Yep. So if you've got a nice stable clock that can run perfectly, then you're encoding stuff, and it's most important at the A to D side, right? Because you want to encode it in a perfect time interval so that when it plays back, it's, you know, as perfect as it went in. So that's been, I think that's one of the reasons that these sound so good, and the imaging is so good.
Yeah, I mean, when we heard the orchestra in the room, which was a great experience itself, and then heard it back, it was really interesting because we heard the different mic balance as to the human ear, and they were making more of the room, which sounded amazing, and it just sounded really alive, and it was literally the whole string session, no mixing, straight back in, and it just sounded very clean.
Well, and what you'll hear, you know, where those artifacts would show up and sort of, you know, mess your recording up in rhythm section stuff is the transients, and, you know, the things that have a very short time cycle. You know, things that spike, like the front end of a drum, the front end of a guitar pick, you know, things that have a high sample frequency or a high frequency rate. So by, you know, giving us a nice stable platform, the drums just sound great. You know, when you were in here, you were listening to, you know, everything that we were processing in console, and, you know, it really sounds together. It gives it a totally, you know, firm image, and there's nothing drifting. There's nothing sort of hypey about it. You know, it just sounds very flat and natural.
So you've gone for 6 cores.
Yep.
Is there a reason you went just 6 straight across the board rather than, so, I don't know, 8 or 10 or 12? Because I mean, previously you've iterated the number of DSPs.
That's right. Well, this is to allow 6 cores and to produce 6 cores in a unit like this took some serious redevelopment of our FPGA technology. So an FPGA is the traffic cop in the middle of the box.
You've got to move a lot of data around.
Oh yeah, and so we were fixed. They're basically just a computer mapping system that allows you to map a bunch of pins together. So we were out of pins, and that was we couldn't add any more DSP or any more I/O, without running out of pins. So that's where we were before. Now we've added a new FPGA architecture that allows us to scale a little bit. So this is the first that we're able to support more.
So this has got enhanced capacity effectively now.
It does.
This architecture.
Yeah, we have headroom. We have headroom.
It sounds like So you've redesigned the clock. You redesigned the mic amps the same, or have they been tweaked as well? I mean, it sounds like a complete rework.
Yeah, the mic amps are similar. What we've done some work on them with the power supply, the shielding. Basically, one of the things that is we don't talk about very often is the actual physical components that we use in the things. We are using super premium resistors and transistors and all of the components that make the system. So by increasing the quality, reducing the tolerances, one of the things that becomes expensive with these things is you can buy the same rated component, but it'll have a wider tolerance. Right. So some units may perform like this, some units may perform like that. By tightening that down across the board, we've invested and spent more money on the componentry, and we gain that, and then we're able to tweak the tolerances of the circuits and push things up. So that's how we get great dynamic range, really low THD plus noise, great signal to noise ratio, all the things that go in and make the box have a sound.
Right.
Yeah.
So are we going to see now? I mean, obviously this feels like a step up from the platform. You say it's the third iteration, and it gives you more headroom. Are we going to start seeing some more ambitious software projects to go and take advantage of all of that lovely? I mean, because there are some things that you make that take like almost a whole DSP because they're so involved and kind of complicated in what they do. I mean, I guess can you go further
with more DSP, or just further with the design?
With the software that can run on it, I guess.
Yeah. Oh yeah. For example, in Q4 we're going to have surround monitoring. So that's another. It uses the same line outputs as the line outputs, but it gangs them together under a single volume control, and making those things be perfectly matched, gain matched within phase a tenth of a dB. They have to be phase aligned. They have to be very very carefully controlled, and so we've been able to add that, and that's code that it takes more memory space. It takes more horsepower to run that.
Well, that's the one thing that Fab was saying is a lot of surround sound mixes are now done completely in the box.
That's right.
So, but the hard thing is the monitor controllers for that. So this kind of solves a problem that's been around for a while, right?
That's right. That was the idea, is to give people an interface with the monitor controller, because in a lot of workflows you'll see studios like pre-production suites that have an interface and then a very expensive monitor controller that lets them do the room, the speaker equalization, do calibration. So you have to be able to work in dB/SPL mode so that you're working to a fixed volume level. So we've added all that stuff in.
All right, so that's all going to happen. That's not at release though, is it? That's coming along.
Yeah, it's coming. It's coming in Q4. We're going to show it at AES coming up in just a few weeks. So we're well on our way to developing that. But it's really cool to be able to just go in. The way we've caused the surround functionality to work is we have a pull-down menu that lets you select the mode that you want to work with, and we've covered pretty much all the modes that are out there. So there's 3 flavors of 5.1, for example. Film, SMPTE, and DTS. Each one of those has a different stream order, and what we do is we identify what the stream order is when we load the preset, and then that becomes your I/O,
right?
And then your DAW can just.
So does that use up some of the available DSP, or is that sort of system level stuff? It's system level
stuff, right, but it takes more memory, more overall system memory, and you'll see. I mean, we run the mixer itself is a DSP function, so it takes a certain amount of DSP to run that.
So we've got 4 models. We're seeing the 8
yes.
and the XPs here, which are they're for different uses. So the 16, that seems to have a wider dynamic range, and it's the one that you're using in the recording. That was more just the straight interface.
That's right.
You don't get the unison on that.
No, there's no mic preamps on it. So that's really, I mean, as you say, they're all designed to sort of fall into a particular workflow or a particular client's needs. So going from the smallest to the largest, the X6 is the new interface complement that we haven't had before. It has 2 unison mic preamps, 6 line inputs, and 6 line outputs. So
it's almost like a twin on steroids.
It's a rack mount twin.
Yeah,
you might look at it like that. And but you still get the hexacore processing. So if you're a person that's doing EDM music, or you've got a lot of soft synths and you don't need a lot of external inputs, the X6 is perfect. The 8 is more like the Apollo 8 from today. So you have 4 mic preamps, 8 line inputs. It's really it's got the most gear changing. You've got a dedicated SpeedF output. You've got dedicated ADAT. The 8 XP has 8 mic preamps. The P stands for preamps, and of course,
if you need them, you can just buy them. So is there is there a point at which, how many can you chain up? If you need a whole bunch of inputs, how many 16s could you put on a system, for instance?
You can have, in our system, you can have up to 6 U82 devices in a chain. So 4 of those can be an Apollo. So what that means is you can have 4 Apollos and 2 satellites, or 4 Apollos and 2 PCIe cards.
Okay, right. So you could get up to, so that would be 16, so 48 I/O. Or more, a bit more with the 16X, isn't it? It's 32, 48 in and
64. You'd have 64.
Yeah. My maths was always bad.
Well, mine too. But yeah, 64 I/O in and line out. So there's a great, a tape recorder replacement right there. 64 tracks.
And the other question that's obvious, I mean, you must get this a lot. You're working to this kind of super real-time, zero or very near zero latency real-time systems.
Yep.
But you don't make any virtual instruments.
That's true. But we support virtual instruments. So that's the cool thing with the Apollo workflows. You can take a virtual instrument that's being generated in your DAW or in your third party and run it into a virtual track, and then do U82 processing and then play it back or record it. So yeah, instruments, that would be a really fun thing to do.
So is there any other adaptations? We've got the hardware iteration. Is there new stuff that's happening within console that the new hardware allows you to happen, or is there updates there that we should look out for?
Yeah, probably the most notable is our operating level. We've added plus 24 dBu operating level, so it's switchable between plus 20 and plus 24. So the original Apollos were all plus 20, and that's just changing the voltage acceptance on the input and the voltage return on the output. So most of the studio gear that you're looking at here, the consoles and tape decks, want to run at plus 24 dBu. That's a fixed, 12.2 volts out at 24 0 dB. FS would be 12.2 volts. So we are able to do that now and accept that same voltage level on the way in.
And it looks like that's, demonstrating it here, especially on the string section, it's kind of like, well, I guess your dream is to see these racks in every studio that's tracking,
That's right.
Yeah.
And you have to, if you're going to work with a Neve console, you need to exercise the bus, and that's why they have 26 volt rails.
So availability and pricing, I don't know if you've got that information, but you might know about the availability. So all 4 coming out simultaneously?
They're out now, yes.
Right.
They hit the channel today.
Right.
Wait a second, this is the 11th. It hit the channel Thursday, last week. So
people can buy them now, and
yes.
They're high end, but they're still, for what you get, it seems like there's kind of, it's still reasonably affordable when you consider what it would cost you to do this any other way, right?
The X6 is less than 2,000 US, so $19.99. So there's your entry into 6 DSPs, 2 unison mic preamps, the whole complement of other digital inputs and stuff on the X6. So that's, for less than $2,000, you're getting into the Hexa range. Then for $24.99, we have the X8P. I'm sorry, the X8.
Yeah.
29 is the X8P, and then 34 is the
big guy from the studio.
Yeah.
Okay, so one last question: are you considering including a USB-C to Thunderbolt 3 cable out anytime soon?
Oh man!
Because we get it and you go, oh, I haven't got the cable.
Yeah. You know, we talk about that, and they're so expensive. We can't buy them for any less than anybody else can. So there's processing in the cable, so we would have to increase the price, and I don't think that that's fair to the customer. So no, probably not.
Gannon, thank you very much.
You're welcome, sir. Thank you.